Watch a developer try to build a complex project with a standard AI assistant, and you'll eventually see them hit a wall. When a task requires massive amounts of context, the interaction inevitably breaks down. This frustration stems from a technical limitation. Most current large language models follow a single-threaded, sequential logic path, meaning they process information one step at a time. This leads to serial collapse. When an AI attempts a 100-step task linearly, its coherence fades. The further it gets from the original prompt, the more it hallucinates, until the entire logic chain collapses. Professional engineering doesn't work in a straight line. Real-world development requires managing dozens of files, tracking dependencies, and testing functions all at the same time. Because their core architecture was built to predict the next word in a sentence, legacy AI models are structurally incapable of acting as truly autonomous workers. In early 2026, Beijing-based Moonshot AI released KIMI K2.5 and K2.6, designed specifically to solve this sequential bottleneck. While it features a massive 1 trillion parameter scale, Moonshot optimized the system for execution and task completion rather than standard conversational fluency. Crucially, KIMI is an open-weight model. While most frontier labs hide their weights behind private APIs, KIMI's model architecture is accessible to any developer. Moonshot built KIMI to serve as a parallelized, autonomous workforce for complex engineering. Operating at this scale usually requires immense computing power, but KIMI uses a mixture of experts design to stay efficient. As this diagram shows, the model doesn't use all 1 trillion parameters for every request. Instead, it activates a specific path of just 32 billion parameters, providing frontier-level intelligence at a fraction of the hardware cost. This efficiency comes from native INT4 quantization. By training the model to work with 4-bit weights from day one, Moonshot achieved a 2x increase in inference speed while cutting GPU memory requirements in half. That speed enables native multimodality. Moonshot trained KIMI on 15 trillion visual and textual tokens simultaneously, ensuring the model understands both types of data in unison. This powers a capability called visual coding. KIMI's MoonVit encoder can look at a UI mockup or a video walkthrough and immediately generate production-ready React or HTML. Because of its unified training, the model understands spatial relationships and design intent that text-only models consistently fail to capture. The real breakthrough is the agent swarm. A single prompt triggers a central orchestrator to spawn up to 100 specialized sub-agents that work concurrently. These agents work in parallel, one researching, one coding, and one testing, before the orchestrator synthesizes the result into a finished deliverable. This shift to parallelization creates a 4.5 times reduction in execution time compared to traditional sequential AI. Moving from serial steps to a parallel swarm is what allows the model to function as a truly autonomous agent in 2026. The technical results are clear. On humanity's last exam, KIMI K2.6 scores 54%, placing it in direct competition with proprietary giants like GPT-5.4 and Claude Opus 4.6. But the economic disruption is even more dramatic. KIMI's API costs just 60 cents per million input tokens, a 17 times cost difference compared to top-tier Western models. This price point makes massive agentic workflows economically viable for startups and small businesses for the first time. Additionally, the modified MIT license gives developers the freedom to build commercial products without the restrictions typical of proprietary systems. By offering frontier performance at a fraction of the cost, KIMI has become the first credible threat to the proprietary AI monopoly. Because it is an open-weight model, developers can self-host KIMI using VLLM or SGLang, completely avoiding cloud vendor lock-in. This offers a massive security benefit. Organizations can keep their proprietary codebases on private server racks while still utilizing world-class AI. Developers are reclaiming control, hosting their own frontier-level autonomous models on private infrastructure today. The future of engineering isn't a smarter chatbot, it's an open-source, multi-agent workforce controlled entirely by the developer.